Previously, we had shown how to graph our categorical variables. Well, now what we're going to do is we're going to graph the continuous variables. There are a number of different charts that we have, and some are going to be a little bit more intuitive than others, but we'll explain all of them. A dot plot is used to graph every single occurrence, and it's similar to the column chart that we had shown before. It just represents the actual number of each value, and it can make visualizations clear for small data sets. So here we took every single observation and we plotted it on this graph, and this would be in Excel a scatter plot where it was 64 and we had 3 of them, so 1, 2, and 3. The horizontal axis identifies each unique value in the data set, while the vertical axis is the count for each unique value. Each dot represents a single value within the bin. So we could see that there were 3 of them in terms of the frequency there at 64. A histogram will graphically display the frequency distribution by using a column chart. Although it's possible for histograms to be represented horizontally, we generally don't do that. If we convert the level counts into a column chart, a histogram is obtained. Using the student's grade example, a column chart is created from the counts of the levels. So we have our bin 1, 2, 3, 4, 5, which are ranged 60 to 67, 68 to 74, and so forth. And we have our counts 7, 3, 2, 3, and 6, which are the counts represented in the bar chart. You're going to notice at the bottom here, this histogram has 60 to 67.2, and that's because this chart was created in Excel, which automatically creates the bins for you. Again, we'll show you that in the Excel video, but this concept is still the same because there is no 67.2. What you will notice is the parenthesis and the brackets. The brackets mean inclusive of that number. So the 60 with the bracket there to the left means it includes 60. In the next column, you'll see that it says 67.2 with a parenthesis. That means it's greater than 67.2. And if there was a 67.2, it's not included in that bin. It's actually included in the one before it. So as we said, Excel will automatically create a histogram from a set of data by selecting the histogram chart option. It automatically creates it with a set number of bins, which you can change. And it should be noted that the numbers on the x-axis are encapsulated with a bracket or parenthesis that show the range or the level. In the example below, we have the numbers. The bracket indicates that the number is inclusive, and a parenthesis means that the number is not included. So the notation 74.4, 81.6, parenthesis and bracket respectively, means that the range does not include 74.4, but everything above 74.4 through 81.6 inclusive. Histograms can show the shape of the data and display interesting patterns, including hills, valleys, skewness, and the characteristics of tails to the right or to the left. Here on the left side, we have a skewed left because the tail is to the left. So when we talk about skewed left, skewed right, we're talking about where the tail is. So this one is skewed left, so we have the tail to the left. On the one on the right, we have skewed right because the tail is off to the right. Now, a stem and leaf chart is an older text visualization of data. It represents the data in rank order, and many statistical applications can make a stem and leaf plot, but you got to do this manually if you're going to do it in Excel. The plot is made by taking the leading digit of each of the observations. So in the student example here, we have the numbers 6, 7, 8, 9. These numbers create the stem of the chart. And the leaves of the chart represent the other digit at the end, representing each of the observations in the data set. So we're going to split this out, and we have 60s, 70s, 80s, and 90s. And you can see here those are 4 stems. Now, if you had 102, you would have, your left would be a 10. If you had 150, that left side would be 15. It's only the last digit that you're going to end up using for the right side or for the leaves. So here we have a 60, a 64, another 64, another 64, a 66, and a 67, and another 67. So there are 7 items in that 6 stem. There are 4 items here in the 7 stem, which is 72, a 72, a 73, and a 79, and so forth. And it shows you the groupings of the items. And if you tilt this a little bit, like you rotated this 90 degrees to the left, you'd actually see that it's trying to form a bar chart or a histogram. Just got to take a little bit of imagination here with the graphics, but that's the way this was done, and this is how these types of histograms were created prior to the graphical systems that we have today.